This is my predicted paper for paper 2, 3rd of June 2024. So we've had paper 1 now, I've had a look at that, and these are the topics that I think are likely to come up on paper 2. I hope you enjoy it. This is for the higher tier for Edexcel, 3rd of June, paper 2. Okay, calculator paper, this one. So question number 1, I've gone for a scatter graph. The scatter graph shows information about the number of likes and shares of 10 different posts to a social media account. So we've got number of likes on the y-axis and number of shares on the x-axis. It says one of the points is an outlier. Write down the coordinates of this point. So an outlier is a point that does not fit the trend of the data. And we can see that the data is following a pattern over here like this. This point here does not fit the trend of the data, and so we would say that that is an outlier. Now be really careful when you're reading off the axes. I've been quite crafty here. I've gone 26, 27, 28, 29. So this is going to be 28, and then in this direction we can see that that is 30. So 28, 30, remember, along the corridor, up the stairs, that's going to be how you read the coordinates of that outlier. For part B, for all the other points, write down the type of correlation. Correlation is either positive or negative. In this case, the pattern is going up. The more likes the post receives, the more shares the post receives. So positive correlation there. You can put weak or strong, it won't make a difference, as that word positive is what's going to get you the mark there. And then for part C, the same account makes an 11th post which had 72 likes. Estimate the number of shares this post had. So we're going to use our line of best fit here. If it had 72 likes, we're going to go to 72 on this axis, go across, hit the graph, and then go down. And I get 8 for that. I think 8 or 9 there, you'd be absolutely fine. So I'm going to go with 8, but I think I also got 9 when I did this paper earlier. So 8 or 9 there would be all good. Question number 2, write 612 as a product of its prime factors. Give your answer in index form. So we start with 612 at the top, and we need two numbers that multiply together to give 612. I'm going to go for 306 multiplied by 2. So I've halved it there to get that. Now 306 is in the 3 times table. I can tell because 3 add 0 add 6 makes 9, and 9 is in the 3 times table. So I'm going to divide it by 3, and that is 102. You can use your bus stop method if you're not sure. 102, that's half it. Let's go 51 times 2, and then 51 is 17 times 3. Again, if you can spot that it's in the 3 times table, use the bus stop method to divide by 3 and work out what's left. All of those numbers that are circled are prime numbers. So now we're going to write our answer as 2 times 2 times 3 times 3 times 17. Those are all our prime numbers there being circled. All our prime numbers that are circled being multiplied together, and that would make 612. Now, to get full marks here, we need to give our answer in index form. So we're going to write 2 squared times 3 squared times 17. You don't always get that second line, but if you do, you need to write the powers. Okay, question number 3. Write 0.0409 in standard form. Standard form is writing a number as a number between 1 and 10. Times 10 to the power of something. So I need these digits, so 4.09. Always for standard form, we're putting times 10 to the power of something. Now, if it's smaller than 4.09, we need to do a power that is negative. So if I need to, which here, I've got 4 here, and I've gone into the 10ths column, into the hundredths column. So I've divided by 10, divided by 10. And that's the same as timesing by 10 to the power of negative 2. So if you're dividing by 10 twice, it's the same as timesing by 10 to the power of minus 2. So a really, really small number is going to have that negative power. For part B, write 2.38 times 10 to the power of 7 as an ordinary number. So this time we're timesing by 10, timesing by 10, timesing by 10, 7 times. So 2.38. If I times by 10 once, I'm going to get 23.8, times by 10 again, and then I've got 5 more jumps. So I'm going to fill in those gaps with zeros, And my answer here would be 238,000,000, which is 23,800,000. For part C, it says work out the value of 1.4 times 10 to the power of minus 5 divided by 2.7 times 10 to the power of 2. Give your answer in standard form, correct to 3 significant figures. Now for this, we're just going to use our calculator. I'm actually writing that first number on the top of the fraction. I just think it's a little bit easier to make sure that it does the correct order of operations. 2.7 times 10 to the power of 2. So using my calculator, I'm typing that in, 2.7 times 10 to the power of 2, and that gives me an answer of 5.185185 times 10 to the power of minus 8. Now, my calculator has given that to me in standard form, but I do need to round it correct to 3 significant figures. So for significant figures, we are starting counting from the beginning of the number. So 5 and then 1 and then 8. And we check the next number because it's a 5, it rounds up. So my answer here is going to be 5.19 times 10 to the power of minus 8. For question number 4, a number h is rounded to 1 decimal place. The result is 2.1. Write down the error interval for h. So an error interval is going to show us the smallest and the biggest the value could have been before it was rounded. If we've rounded to the nearest 1 decimal place, we've rounded to the nearest 0.1. Now we would divide that by 2, which is 0.05, and that is going to tell us how much to go above and how much to go below. So from 2.1, we're going to go 0.05 below and 0.05 above. So that's 2.05 for our lower bound and 2.15 for our upper bound. You might be thinking, well, hang on, 2.15, wouldn't that round up? And that's why we've got the inequality symbol there that's just less than. So we can go up to 2.15. We can't technically equal it exactly, but we can go so infinitely close that we're just going to call that the upper bound. So there we go. Question number 5a, expand and simplify. So we're going to expand out our brackets here. Now I've been a bit sneaky with this second bracket. I've subtracted the whole bracket. Now that's the same as taking away one lot of each of the things in that bracket. So when I expand this here, I've got 8k add 4, because I'm doing 4 lots of 2k and 4 lots of 1, minus k, but this should be an add 2, because I'm subtracting that minus 2, and taking away minus 2 is going to add 2. So overall here, 8k, take away k, that gives me 7k, and then I've got positive 4, add 2, which is positive 6. For part B, we're simplifying 3a to the power of 4b squared times 3a to the power of 4b squared times 3a to the power of 4b squared. We are cubing it, so we're timesing it by itself and then by itself again. Now the 3 times the 3 times the 3, that makes 27. So that 3 is being cubed, as you would expect. Now with the other values, you can either look up here and say a power of a power, we times the powers together, or you can look at the fact we've got a to the power of 4, a to the power of 4, a to the power of 4, and we can add those powers together. Either way, we get a to the power of 12 and b to the power of 6 there. Question number 6. These are both right-angled triangles. ADC is a straight line. Work out the length of CD. Give your answer correct to 1 decimal place. I'm going to pop an X here so we know what it is that we're working out. This is what we're being asked for. Now, at the minute, I don't have enough information in this triangle to work out the value of X. So I'm going to start over here in this triangle. I've got the hypotenuse, and I want to know this side here, the opposite. The reason I want to know that side is because that side is in common to both triangles. So if I can work that out, it gives me more information in that triangle on the right. So to work that out, I've got the hypotenuse and I want to know the opposite. So out of SO, cat and TOA, I'm going to use SO. The adjacent is down here and I don't know it and I don't want to know it. So I don't want to use cat or TOA because that involves the adjacent. Now, if I want to know the opposite, cover that up and do the sum that's left behind. So that's going to be sine 37 multiplied by 12.4. Now, again, you're going to type that in your calculator. You don't want to round this. So this isn't my final answer. So I don't want to round it. I just want to keep it exactly as it is. On the paper, I'm going to write a few decimal places, but I'm going to keep it in my calculator just so I keep it nice and exact. That is this side here. So I now know that this side is 7.46 and so on. Looking then at this triangle, I now know this side, and I want to know this side. So when you know two sides of a right angled triangle and you want to know the third side, that's going to be Pythagoras. So I'm going to do 9.3 squared, take away this value, 7.46 squared, and then I'm going to square root my answer. Now it's a subtract because you have the hypotenuse, you have the longest side. So I'm going to do 9.3 squared. In my calculator, I'm actually typing minus that answer squared, and then I'm square rooting it, and that gives me an answer of 5.54986. We were told to round it to one decimal place, so 5.5 is going to be your final answer for the value of DC or CD. Okay, question number 7. The frequency table gives information about the length of 50 parsnips. Find the class interval that contains the median. So there are 50 parsnips here. This adds up to 50. If we want to know where the median is, remember the median is the middle. If I want to find that middle value, I would add 1 and divide by 2. That tells you the position of the middle piece of data, and that is 25.5. So where is the 25th and where is the 26th piece of data? We want to go in between them. So at the end of this category, I've had 2 of the smallest parsnips. At the end of this category, I'm now up to 7. So I've still not reached that middle value. At the end of this category, if I add on another 15, I get to 22. So I've still not reached the middle value. But by the end of this category, if I add 20, I'd be up to 42. So my 25th and my 26th piece of data fall in this category here. This is the class interval, the category. So we're going to write exactly that on the answer line, 15 to L to 20. There we go. On the grid, draw a frequency polygon for the information in the table. Now, for a frequency polygon, it ends up looking a little bit like a shark fin. So we call her Polly the shark. If you know, you know. I've put that down here. So that was my explanation for that. So Polly the shark, if you have heard me talk about that before, hopefully that's stuck in your head. So we go in the middle of the category. Polly, she lives in the middle of the ocean. So if we've got 0 to 5 and a frequency of 2, then we're going to go up to 2, which would be there. Every 2 squares is 1 in that direction. Watch out for that. So again, we're going to go in the middle of the category. So halfway between 5 and 10, we're going to go to 7.5 and go up to 5. The next category, we're going to go across to 12.5 because that's in the middle of the category there, and up to 15. So that'll be there. Next one is going to be 17.5 and up to 20. And last but not least, we've got 8. And that's going to be at 22.5. So let's go 6, 7, 8. There we go, like that. So be really careful with your axes and checking that it's not going up in 1s or going up in 2s, whatever it's going up in. There we go. So it's not always going to make a perfect shark fin, but it looks like that. The other thing I will say is please do not connect it to the origin. Polly is a shark. She likes to be out at sea. She doesn't want to be anchored to the shore. There we go. I know it's really silly, but hopefully it helps you remember what the graph looks like for a frequency polygon. Polly the shark lives in the middle of the ocean, so we go in the middle of the category. Okay, lovely. Question number 8. The probability tree diagram shows the probabilities that Megan will be late for work on Saturday and on Sunday. Calculate the probability that Megan will be late on exactly one of the 2 days. So we don't mind if Megan is late on Saturday, but then she has to be not late on Sunday. Or she can be not late on Saturday and late on Sunday. So we only want her to be late on one of the days. With a probability tree, we are multiplying along the branches and then adding them up at the end. So for this branch, it would be 0.23 times 0.9. Let's type that in your calculator. 0.23 times 0.9 is going to be 0.207. And for this category, for this branch, 0.77 times 0.12 is going to be, let's write that, working times 0.12 is 0.0924. All we then want to do to get the total probability of either of those things is to add those probabilities together. So add 0.0, No, 0.207 to that value, and we get 0.2994. There we go. I've not been told to round it. That's the whole answer, so I'm just going to put all of that on the answer line. 0.2994 is your total probability that she would be late on exactly one of the 2 days. Question number 9. Here is a trapezium and a circle. The area of the trapezium is equal to the area of the circle. Work out the diameter of the circle. Give your answer to 3 significant figures. So the area of a trapezium, there is a formula in the front of your exam this year. So it's half A plus B multiplied by the height. I prefer to think of it though as A plus B divided by 2 times by the height. Now that is exactly the same thing, but the reason I think of it like this is because for me, when you're working out the area of a trapezium, it makes sense if you're averaging A and B. So A and B are your 2 different widths. So we're saying that it's going to be 5 add 12 divided by 2. So we're averaging how wide it is, and once we've got that average, we times it by 7. So use the formula in the front if you forget, but if you'd rather think of it as an average times by the height, hopefully that might help you to make sense of it as well. So 5 add 12 is 17. 17 divided by 2 is going to be 8.5 times by 7, and 8.5 times 7 is 59.5. So we've got the area of the trapezium, 59.5, and we know that that is equal to the area of the circle. So 59.5 equals pi r squared. Now let's solve this. Let's divide both sides by pi. So 59.5 divided by pi gives us 18.9394 and so on, and that has to be our radius squared. So if we want to know what the radius is, we're going to square root that value. So again, I've not cleared it from my calculator, I'm doing the square root of that answer, and that is 4.35194. Again, I'm not going to clear it. That is not my final answer because we were asked not for the radius, but for the diameter. Now the radius goes from the middle of the circle to the edge, but the diameter goes all the way across. So the diameter is double. So to get the diameter here, we need to multiply that by 2, and that is 8.70389. Again, I just took the answer that was in my calculator and doubled it, and we're rounding this to 3 significant figures. So 1, 2, 3, check the next number, it's a 3, rounds down, so 8.70 is your answer there. Question number 10. Matt and Damien share 210 dice in the ratio 2 to 5. Now for ratio questions, I like to write them out 2 to 5 like that. We've got 210 dice to share over these piles, and in total we have 7 piles or 7 parts. So I'm going to start by doing 210 divided by 7, which is 30. So each of these piles has 30 on them. So to begin with, we can see that Matt on this side, Damien on this side, Matt has 60 and Damien has 150 to begin with. But Damien now gives some of the dice to Matt. And that means that Matt's going to go up, Damien's going to go down. And now they're in the ratio 2 to 3. But the number of dice hasn't changed. We've still got 210 dice. So I'm going to now take 210 and share it in the ratio 2 to 3. 210 divided by 5 is 42. So 42, 42, 42, 42, 42. So now we can see that Matt has 84, and 42 times 3, we can see that Damien has 126. So work out the percentage increase in the number of dice Matt has. Well, Matt's has gone from 60 to 84. When we are doing percentage change, increase or decrease, or even profit, it is the change, which in this case is 24, over the original times by 100. 24 over 60 times by 100. Typing that in your calculator, that gives you 40%. Question number 11. Katie has 10 t-shirts, 2 pairs of jeans and 3 skirts. She's going to choose an outfit from either a t-shirt and a pair of jeans or a t-shirt and a skirt. Work out the number of different outfits Katie can choose. So if she went for a t-shirt and a pair of jeans, she's got 10 t-shirts to choose from and 2 pairs of jeans. So 10 times 2, there are 20 different combinations there. Or she's going to go for a t-shirt and a skirt, which would be 10 times 3, which would be 30. Now, we don't want to times these values together. We're just saying it's either going to be this or this. And so what we're going to do is add those values together. So it's either going to be one of the 20 combinations for a t-shirt and a pair of jeans, or it's going to be one of the combinations for a t-shirt and a skirt. And we're adding those values together. So that is 50. 50 would be your answer there for 3 marks. Question number 12. Now, if this question comes up, you do now have a calculator for this. And there's a couple of different ways you can do it. I am going to upload a video on how you use your calculator to do this. However, I think it's just as easy to use brackets. So in your calculator, I would take this, and every time you see an X, I want you to put brackets. So in your calculator, you're going to type bracket, bracket squared, minus 2, bracket, bracket, minus 1. That is then going to allow you to just change whatever numbers in the brackets to be each of these values here. Okay, so we're going to start by putting minus 2 in the brackets. Minus 2 squared, minus 2 lots of minus 2, take away 1. And that's going to give you a value of 7. You're then going to go back, left-hand arrow, and change what's in these brackets to be minus 1, the next value. So minus 1 squared, minus 2 lots of minus 1, minus 1. And that's going to give you your next value of 2. And repeating that process with a 0 and then a 1 and then a 2, we get minus 1, minus 2, and minus 1. Each of these is coordinates that we're going to plot on the grid. So minus 2, 7 is up here, minus 1, 2. We've then got 0, minus 1, 1 minus 2, and 2 minus 1. This is a quadratic graph, so we're going to draw it with a nice smooth curve, like that, and back up here. And it would continue on, but we don't need to go beyond that. That's all we've been asked to draw. Okay, then it says, using your graph, find estimates for the solutions of the equation x squared minus 2x minus 1. Well, that's what we've just drawn, equals minus 1.4. So when does your quadratic graph equal minus 1.4? Well, minus 1.4 is here, 2 little squares below minus 1, because each of the squares is 0.2. And then we just need to look and see where that crosses the x-axis. So I've got there, and I've got there. Now I think for this I would accept a small range, let's say from 0.1 to 0.3, and for here let's say I would accept from 1.7 to 1.9. I've ended up in the middle of those, so let's go 0.2 and 1.8 would be my answers there. Don't write them as coordinates. We're not looking for coordinates unless it says coordinates. It's just saying what value of x would solve this equation. And so we're giving the two x values, 0.2 and 1.8. You could put or if you liked, but don't write it as a coordinate. That's a really common mistake. Question number 13. Jean invests £5,000 in a savings account. The savings account pays compound interest at a rate of X%. After 3 years, Jean has an extra £559.67 in interest in her savings account. Work out the value of X. Give your answer to one decimal place. So with compound interest, we would normally say, right, £5,000 multiplied by something to the power of 3, because it's 3 years, equals, and it's going to be £5,559.67 because we've got this much on top of her initial investment. So what I'm going to start by doing is £5,559.67 divided by 5,000 to get this value here. So we're just dividing that, we're working backwards, and that is going to be 5,559.67 divided by 5,000 is 1.111934. Okay, but that value has been cubed. So I'm going to do, let's put that as x cubed. So I'm going to cube root that value. And so x is 1.03599. So that is the multiplier. Now, if the multiplier is 1.0359, to get what percentage that is, I would times it by 100. So multiplying that by 100 tells me that it is 103.599 and so on which means the interest is the extra money on top. So let's take 100 away from that, and we can see that it would be 3.599%, and so on, which we're going to round to one decimal place. So 3.6% would equate to that amount of interest over the 3 years. Question number 14. The diagram shows a cylinder. The cylinder has a radius of x minus 3 centimetres and a height of 7 centimetres. The volume of the cylinder is 80 pi. Work out the value of x. So the volume of a cylinder, we do the area of the circle multiplied by the height. So pi r squared times by the height, and we're told here that that equals 80 pi. So pi times the radius squared times by 7 equals 80 pi. Now both sides of this equation have pi, so I'm going to divide both sides by pi, and that's going to get rid of those. When we have a bracket squared, you need to write that bracket out twice and expand it. Don't fall into the trap of just doing x squared add 9. So it's going to be x squared minus 3x minus another 3x add 9. And that is x squared minus 6x add 9, except it's all being multiplied by 7 from here, and that equals 80. So the next line of my working would be 7x squared minus 42x add 63 equals 80, which is a quadratic. And to be able to solve a quadratic, we need it to equal 0. So I'm going to subtract 80 from both sides, which is 7x squared minus 42x minus 17. Now, notice in the question you were told to round your answer to 2 decimal places. That is telling me that this is probably not going to factorise. So I'm going to use the quadratic formula here, minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, a is 7, the number in front of x squared, b is minus 42, and c is minus 17. So we're going to do minus 42, so you can just write 42, plus or minus the square root of, now, if you're putting minus 42 in here, you'll need to put it in brackets, or because it's negative, a negative squared is a positive, so if you just want to put 42 squared, that's fine. Minus 4 times 7 times minus 17, all over 2a, which is 2 times 7 or 14. Typing that in your calculator, the first time you type it in, you're going to use the plus, and the second time you type it in, you're going to use the negative. So using the plus, I get 6.38 and so on, and using the subtract, I get minus 0.38, so on. However, x cannot take a negative. In fact, it can't be anything less than 3 because then the radius would be negative. So we're going to disregard this one, and we're going to say our answer is 6.38 to 2 decimal places. Question number 15. The points B, E and D lie on the circumference of a circle. AED is a straight line. ABC is a tangent to the circle at the point B. AE is 12, so we can see that there. BD is 10, so we can see that there. And angle EDB is 41, angle DBC is 55. Work out the length of AB. So let's pop an X here so we know what we're working with. And we've got to give our answer to 3 significant figures. So the first thing I'm immediately noticing is that we've got a triangle on its tip on the tangent, and that is going to be the alternate segment theorem. So if I know that this angle here is 55 degrees, this angle up here is also going to be 55 degrees. So whenever you have a triangle on its tip on the tangent, this angle is the same as this one, and this angle is the same as this one. So by that rule, I've also got 41 degrees up there, so I know that 41 degrees is going to be there as well. Now, in doing that, we've then given ourselves a pair of values, so we can now use the sine rule. However, to be able to use the sine rule, I'm going to need to know this angle up here, and we can get that because we know that angles on a straight line add up to 180, and we've got that straight line there. So I therefore know that this one is 125 degrees. Now let's use the sine rule. It's not SOHCAHTOA because we haven't got right angled triangles here. So we know it's going to be cosine and sine. And there is a way of doing this with the cosine rule. I might do that after as well. So let's just get rid of all of that stuff just so I can kind of see what I'm doing here. Right, so I know that this one was 125. This one was 55 using the alternate segment theorem. And this one was 41 degrees. Now, if you would like this side here, we know that we want a side, we're going to put sides on top. So A over sine A equals B over sine B. So x over sine 125 equals 12 over sine 41. With the sine rule, you have to keep them in pairs. So if they're opposite each other like that, they're going to be a pair. And so now to get x, we're going to multiply both sides by sine 125. So in my calculator, I am typing 12 over sine 41 multiplied by sine 125. And that is 14.98314 and so on to three significant figures. 1, 2, 3, the 8 rounds up. So that is going to be 15.0. Now that wasn't the only way you could have done it. You could have also used the cosine rule. So how would we have used the cosine rule? Well, I would have used the sine rule over here to get this side. And then once you'd worked out this side here, you could then use the cosine rule, these two sides and that angle, to work out the opposite side. So you could have done it that way as well, but you should have got the same answer. So there we go, 15.0, 5 marks for that one. Question number 16, show the equation x cubed, add 5x minus 3 equals 0, has a solution between 0 and 1. So what we want to show here is that one of the values is too small and the other one's too big, and therefore there must be an answer in between. We're looking for a number that when you substitute in here would make 0. So if one of these values is too small and the other one's too big, then we're all good. So 0 cubed, add 5 lots of 0, take away 3, that is minus 3. And 1 cubed, add 5 lots of 1, take away 3 is 3, which is, that one's too small and this one's too big. And we want to write a statement, so therefore solution must be in between. There we go. Part B, show that the equation can be rearranged to give that. So if we're rearranging, let's write it out. So we've got a starting point. Now you can see that they've ended up with a 3 on the top of the fraction here, and they've divided by x squared add 5. So let's see if we can replicate that. I'm going to start by adding 3 to both sides. So if I'm adding 3 here, adding 3 here, I've got that 3 on its own. But I now need to divide by x squared add 5. And the only way I'm going to get x squared add 5 is if I factorise. So x squared add 5, and then we can divide by the bracket. So that is x equals 3 over x squared add 5 for 2 marks. For part C, starting with x naught equals 1, use the iteration formula 3 times to find an estimate for the solution. So whatever they give you as your starting value, x naught is your starting value, you're going to type that in your calculator and hit equals. So 1 and equals. And what that does is it stores it as the answer. Because what I'm going to do next is take this formula and type it in my calculator, but I want that 1 to already be stored in there. So 1 is stored as the previous answer, because then I can type 3 over the answer squared add 5. And what that's going to do is always take the last answer and put it back in, which is what iteration does. So 1 is now in my calculator, I've hit equals and it's stored as the answer. And now I'm going to type 3 over answer squared add 5. And that gives me the next value, so x1 is 0.5. And then all I need to do is hit equals again, and it'll update, it'll use the 0.5 now as my next value, and it'll give me the next one. So x2 is 0.571428, and I'm going to hit equals one more time, a third time, press the SD button, so x3 is 0.56321839. Now this is just going to keep going in my calculator, but as long as you write at least 5 decimal places, you'll be absolutely fine. Now if you kept hitting equals, you would get a more and more accurate solution to the cubic that we started with up here. However, they only asked me to do it 3 times, so I'm just going to write 0.56321839 on the answer line. At least 5 decimal places, please. Make sure it's super accurate. There we go. Question number 17. Y is inversely proportional to the cube of x. So y is inversely proportional to the cube of x. So that's going on the bottom of a fraction. We can't solve equations with fish in them, so we change it to an equals and a k. So there is some value connecting these two things, and then we substitute in the values. So 10 is k over 2 cubed. They're always going to give you a pair, so you can work out what k is. So 10 equals k divided by 8. Multiplying both sides by 8, I find out that k is 80. So if k is 80, we're going to pop that back in there. Y is 80 divided by x cubed. There we go. Okay, find the value of y when x is 0.5. So y is 80 divided by 0.5 cubed. So don't forget to cube that value because it's x cubed. 80 over 0.5 cubed, and that is 640 for your answer there. If it was directly proportional to the cube, then we would do this, and then y equals k x cubed. I did another more difficult version of that in my predicted paper 1. It hasn't come up yet, so it may be there again. I changed it slightly just for variation, but you might want to go back and have a look at that one for the harder version that was on my paper 1 predicted paper. Question number 18. ABC is a triangle. Work out the area of triangle ABC. Give your answer correct to 3 significant figures. So you're given at the start of your exam on the formula sheet that the area of a triangle is half AB sine C. Now I've labelled this intentionally to mean that the letters you might need to look at, little a and little b are sides, capital C is the angle in between. So you can relabel it if you want, but you wouldn't be expected to. You'd just be expected to know that you need 2 sides and the angle in between. So half times 12 times 10 times sine 81. Again, just typing that in our calculators. 0.5 times 12 times 10 times sine 81 gives us a value of 59.2613 to 3 significant figures, 59.3 meters squared for that one. Question number 19, and we have an algebraic fraction. 5 over 2x minus 1 minus 2 over 2x add 1 equals 2, and we have to solve this. So to subtract fractions, the denominators have to be the same. If I had 3/5 and I took away a half, I would need to make this out of 10. And the quickest way to do that is to multiply those values together. So 5 times 2 for the denominator, which would be 10. I then do 2 times 3, which is 6, and 5 times 1, which is 5, and subtract it. So that'd be a tenth. Now, algebraic fractions are exactly the same. So we're going to do this times by this on the denominator, 2x minus 1 times 2x add 1. And then I'm going to do 2x add 1 times 5, so 5 lots of 2x add 1, minus, because it's a minus in the middle, 2 lots of 2x minus 1. So sometimes students call it an upside down picnic bench, but if you're adding or subtracting algebraic fractions, you want to follow that multiplication in that pattern. So we're timesing this by 2x add 1, and we're timesing this by 2x minus 1 in that pattern, and that equals 2. Now I want to get rid of this fraction, so I'm going to multiply that denominator up to the other side. So I'm going to multiply both sides by this. So timesing the left-hand side by this gets rid of the fraction, and on the right-hand side we then end up with it. So I've got 5 lots of 2x add 1 minus 2 lots of 2x minus 1 equals 2 lots of 2x minus 1, 2x add 1. And then we just want to expand out all the brackets. So 5 lots of 2x and 5 lots of 1 is 10x add 5, minus 4x, and then remember that a negative times a negative is a positive, so plus 2. On this side, I'm going to expand the brackets out first, and then I'll worry about the 2 after. So this is 4x squared plus 2x minus 2x minus 1. Now you might have spotted that as the difference of 2 squares. So what's going to happen there is the plus 2x and the minus 2x are going to cancel out. So on the left hand side, this cancels down to be 6x add 7 equals, and now I'm going to multiply each of the things in the brackets here by 2, so 8x squared minus 2. Again, we have a quadratic and I want this to equal 0. So I'm going to make the left-hand side 0, which means subtracting 6x and subtracting 7 from both sides. 8x squared minus 6x minus 9. And we then need to factorise this. Now, to factorise it, it hasn't said round it, so that's why I've gone for factorising. You could use a quadratic formula. It wouldn't make a difference. You could go for that. But I wrote it, so I know it factorises. Is that cheating? I don't know. So we're going to have 4x and 2x. It might be 8x and x, so you'll have to try these values. I'll show you how to split the middle as well, because you might want to do it that way. So I've always just done it through trial and error. 4x and 2x. 9 is probably going to be 3 times 3, so let's pop that in there. And we're trying to make minus 6. So if I do 4x times 3, I get 12x. And 3 times 2x is 6x. I want to have minus 12, add 6, so it comes up to minus 6. So there we go. What makes 4x add 3 equal 0? Well, for 4x add 3 to equal 0, 4x equals minus 3, and x is minus 3 over 4. And for 2x minus 3 to equal 0, 2x equals 3, and x equals 3 over 2. So those are your two answers. X equals minus 3 over 4, or 3 over 2, or 1.5. You could put it as decimals if you'd rather. There we go. Now, if you want to learn how to factorise when there is a number in front of x squared, there is a method called splitting the middle. Now, to split the middle, let's take this 8x squared minus 6x minus 9. You would take the a and the c and multiply them together. So multiplying them together, we get minus 72. And then we're adding to make minus 6. So I'm looking for two values that multiply to make minus 72, but add to make minus 6. So 12 times 6 would do that, wouldn't it? 12 times 6, good. And then what we do is we rewrite this middle bit as minus 12 add 6. So 8x squared minus 12x add 6x minus 9. You then factorise the first two terms and factorise the second two terms. So this bit is going to be 4x, 2x minus 3, add, and then the second set of 2 is going to be 3 on the outside, and then 2x minus 3. If you've done it correctly, your brackets should be matching. And so altogether, I've got 4x lots of the bracket and 3 lots of the bracket. So altogether, 4x add 3 lots of 2x minus 3. That equals 0, and then from there, it's the same as we did here. So that's called splitting the middle, factorising by splitting the middle if you want to practice some more of that. I've always done it through trial and error, but it is entirely up to you. Okay, question number 20. A car travels a distance of 450 miles in 8 hours and 30 minutes. The distance is measured to the nearest mile. The time is measured to the nearest 5 minutes. By considering bounds, work out the average speed of the car to a suitable degree of accuracy. You must give a reason for your answer. So on a by considering bounds question, we need to do the absolute biggest answer we can and the absolute smallest answer we can, and then we can look and compare them. So this is a speed question, so I need my formula triangle, speed, distance, time. Now the distance is measured to the nearest mile. So 450 has been measured to the nearest 1 mile. So to get the upper and lower bound, I'm going to go 0.5 above and 0.5 below. If it's been measured to the nearest 50, we go 25 above and 25 below. If it's been measured to the nearest 100, we go 50 above and 50 below. You're always halving what it's been rounded to. If it was rounded to the nearest 10, we'd go 5 above and 5 below. Here we've rounded to the nearest 1. So we're going to go 0.5 above, so 450.5, and 0.5 below, so 449.5. So those are my two values for the distance. Now for the time, it is 8 hours and 30 minutes. So 8 hours 30, and that's been rounded to the nearest 5 minutes. So I need to go 2.5 minutes above, so 8 hours 32.5, and 8 hours 27.5 for the lower limit. Now you can, if you want, convert that into minutes for your calculation. I personally just like to keep it in hours, but there is quite a nifty way of doing this, so I will explain. If you want the upper bound for the speed, you want the biggest distance divided by the smallest time. So for the upper bound for the speed, we want the biggest distance divided by the smallest time. And for the lower bound for the speed, we want the smallest distance divided by the biggest time. If you want your answer to be as small as possible, you want to divide it by as much as you can. So we want to make that bottom number as big as you can. Okay, so that's going to be 450.5 divided by, now I would just keep this in hours, and to do that you're going to use the fraction button on your calculator with the shift button first. If you press shift and then you press the calculator button, you will get a mixed fraction, and I'm going to type in 8 and 27.5 over 60. You can do it in minutes if you want, you'll just have to faff around with it at the end, getting it back as you want it, but I like to get straight to my answer. So 449.5 divided by 8 and 32.5 over 60. So once you get down to the bottom of the fraction, or you could just do a divide instead of the line of a fraction there, but you're going to use shift and then fraction. That gives you a mixed number, and then you can type it in like that. So this one is 53.261083, and this one is 52.6243, and so on. Now, a lot of students at that point think, well, I'll add them together and divide by 2. That would be sensible. Yeah, it would be sensible, but that's not how we do bounds. So when we are comparing, and this is for specifically when it says by considering bounds, we are going to see how many significant figures they agree to. So if we were to round both of these values to one significant figure, they would both be 50. If I was to round them both to two significant figures, they would both round to 53. 3 significant figures, and they would be different. So what we're going to say here is that our answer is 53 miles per hour because both bounds agree to 2 significant figures. So we're saying that is why I've gone for 53, because if you round them both to 2 significant figures, that's as accurate as you can make it, and they still agree, if that makes sense. There we go, 5 marks for that one. So 53 was my answer there, but you did need to give that reason. Okay, and last but not least, question 21. And I've gone for one of these nasty vector questions. So the diagram shows trapezium OAMB. O to A is A to N is B. X is a point on OB. So X is down here on the bottom line there. ON and AX intersect at the point P. O to P, P to N, so that bit there and that bit there are in the ratio 3 to 2. Find A to X in terms of A to B. Okay, well, always with these questions, if there's a triangle and you've got 2 sides of it, give me the vector for the third side. So we're going to start by saying that O to N is A plus B. Remember, if you're going with the arrow, it's a positive. If you're going against the arrow, it's a takeaway. Which means that O to P is 3/5 of that. The whole line is 5 parts, and to get from O to P is 3 out of 5 parts. So I'm going to do 3/5 of A plus B. So O to P is 3/5 of A, add 3/5 of B. Great. So now that I've got O to P, I'm going to get A to P. So to get from A to P, I'm going to go against this arrow, so minus A, and then add the bit that I just got. So A to P is minus A, because we're going against that arrow to get down to O. Add 3/5 A, add 3/5 B. Now if I have minus 1 whole A and I add 3/5 of A, I can simplify that to be minus 2/5 A, add 3/5 B. Okay. Now I've got no way of getting down to X, I just don't have the information. But I've just worked out that this bit here is minus 2/5 A, add 3/5 B. Minus 2/5 A, add 3/5 B. And we know that because APX is a straight line, it's just a longer version to get from A to X, which means that A to X is taking this vector here and just multiplying it by a number. We're not adding A's or adding B's, it's just a longer version. So I'm going to say it's K, lots of, minus 2/5 A, add 3/5 B. It's just a longer version of it, so it's just multiplied by a number. Might not be a whole number, but it's just a multiple of that if we know it's going in the same direction. Okay, but we also know to get from a to x that we could come down here and across here, in which case a to x could be written as minus a, because we're going against this bit, and along here. Now I've got no idea what O to X is, but what I do know is that it is parallel to B. Because this is a trapezium, I know that this is some amount of B, and I don't know what. So I'm going to say that A to X is minus A, add, let's say, n lots of B. But there's going to be no more A's added. To get from A to X, we're going down here and across here. So it's only going to be minus A and some lot of B. So now let's compare the two different things we got. We know that A to X is minus A, add NB, because we just did that at the top. But we also know it's this. So I am now going to compare that first term. Now in this version, the number in front of A is minus 1, the coefficient is minus 1. And on this version, K multiplied by minus 2/5 would also need to make minus 1. So I'm going to say that minus 1 is equal to minus 2/5 of K. Now we're then going to do minus 1 divided by minus 2/5 to get K, and that is 5/2. So once you know that K is 5/2, we can then substitute it back into this. So A to X is 5/2 minus 2/5 A, add 3/5 B. So this multiplied by this is minus A, and this times this is going to be 15/10 B, which is 1.5. So minus A, add 1.5 B, or minus A, add 3/2 B, however you want to write it, is absolutely fine. And that, there we go, is your final answer for 5 marks on that one. There are some more examples on past papers of really tricky ones like that, where you have had to compare coefficients. But I really hope you found that helpful. Let me know in the comments what you thought of the paper. I'd love to get your feedback, and I wish you guys all the best for paper 2. If you guys want to join me, I am doing a revision session over half term on the Friday. There's more information about that on my website, hannahkettlemaths.co.uk. Thank you so much for joining me, and I will see you guys next time for predicted paper 3.